All right, in this video, we are going to take a look at the conditional probability rule. So we've been calculating conditional probabilities prior to this, but we have just sort of been um, counting the number of elements or outcomes in certain events and working through the problem that way, just directly from the data. So here we want to talk about the rule that we're really using to calculate these conditional probabilities. And so it says if A and B are any two events with the probability of A greater than zero, then the probability of B given A is equal to the probability of A and B divided by the probability of A. All right. And so this formula is handy when you can't do the problems the other way that we've been doing them before by directly looking at the data. Okay, and if you remember when I was talking through that, I kept saying that A is our sample space, right, and that goes on the bottom, and so that's kind of where the probability of A comes from in this situation. And then in the top number, I was saying before, you would count all of the outcomes in B that are also in the event A, right? And if you think about what that is, right, that is just a set of outcomes that are common to both A and B, the intersection of A and B, right? And so that's what this event is, the probability of A and B. Okay, A and B is the event of that. So, all right, and so then we're just dividing those. So really, this is nothing more than a formalization of that process that we were talking about before. And obviously, the probability of A has to be greater than zero, right? Because of the fact that we're dividing by the probability of A, right? So and if it's zero, right, then you can't divide by zero. All right. So let's take a look at an example problem. All right. And here's the problem. I'm just going to pull it up here, and hopefully get this correct. Okay. All right, so this is problem 4.140 from our book, A Claim or Attack. In the article, a functional analysis comparison of web-only advertisements and traditional television advertisements from the 2004 and 2008 presidential campaigns, which appeared in Journalism and Mass Communication Quarterly. Author C. Roberts explores whether a difference exists in purpose and content of web-only ads and television ads created by candidates in presidential campaigns. The following contingency table cross-classifies a sample of such advertisements by purpose and source. The purpose of the ad is classified as a claim if the candidate acclaims himself or herself with positive statements about his or her credentials to be a better candidate. The purpose of the ad is classified as attack if the candidate attacks the opponent's credentials or defends with refutations against the opponent's attack ad. So generally speaking, right, we have this contingency table, and a claim are going to be positive. Hey, here's the great things I did. This is why you should vote for me. Attack is going to be don't vote for my opponent because they're terrible, right, type ad. Or an ad saying that, hey, I'm not as bad as my opponent makes me out to be. So generally speaking, these are going to be negative. These are going to be more positive, all right? And then here over on this side, we have web-only ads and television ads. Those are the two categories, okay? All right, and so in part A, they want us to find the probability of S2. Okay, so that is S2 is the probability that a randomly selected ad is a television ad. Okay, so probability of S2. That is not a conditional probability that we're studying in this section, right? So we would just calculate that the normal way. On the bottom, we'd have the number of ads in our sample space, which is 570, right? And then on the top, we would have the number of television ads, which is given over here in the margin, right? That's the sum of these two numbers. So that's 508. So the probability that a randomly selected ad is a television ad is 508 divided by 570. All right. And part B, they want to know what is the probability of the event S2 and P1. right? Again, that is not a conditional probability, right? That is the probability of the and of two events, right? And so, um, so we just again calculate the normal way that we've been doing prior to this section. So S2 would be that the ad is a television ad, and P1 would be that the ad is an acclaim or positive ad, right? And so we want those that are common to both. That's given by the probability in this cell right here, 332. So there's 332 of those. That would be the top number. And the bottom number, right, would be the total number of ads in our sample space, which is 570. Okay. All right, so that's part B. In part C, they say, what is the probability, obtain the probability of P1 given S2 directly from the table, okay? So the way that we were doing that before, right, is S2 was our sample space, okay? So what that means, right, if S2 is, we're not really considering S1 right here. So S2 is our sample space. And one way you can kind of, that might make it a little easy for you if you're struggling with that, is if we're given that S2 happens, then these numbers, right, are out of the question. Really, this is the only row that we want, okay? And so we're not looking at these. So you can actually cross those out, right, if you want to. And so we're given that the television ad is given that the ad is a television ad. So we're really only looking at these numbers, right? And our sample space, right, would then drop down to 508, right, because that's the total number of those ads. All right, and then we want the probability of P1 that it's an acclaim. That would be 332, right? That's the number that would go on top. Okay. So that is calculating the probability of P1 given S2 directly from the table. And we can do that here, right, because we are given counts or frequencies, which is no problem. All right, now in part D, they want us to calculate the same probability, right? The probability of P1 given S2 by using the conditional probability conditional probability rule, okay? And so let's go back and take a look at the conditional probability rule, right? It looks like this. All right, so we have the probability of B given A, right? So that's going to be the probability of A and B over the probability of A, all right? So in our case, right, the B would be playing the, P1 would be playing the role of B, S2 would be playing the role of A. So going straight by that formula, right, it would be on the bottom, probability of S2. On the top, it would be the probability of S2 and P1. All right, so we are using exactly this rule right here, okay? All right, and you can see that those are probabilities that we've already calculated, right? Up here, we have calculated the probability of S2 and P1 in part B. So that number would go on top, 332 over 570. On the bottom, right, we would have the probability of S2, which is 508 over 570, okay? All right, so you can see there we have a complex fraction, right? That is a fraction that has a fraction in its numerator and denominator, right? And you can simplify a complex fraction by just doing fraction division, right? So I have one fraction on top divided by the other fraction on bottom. What you would do, right, the rule to do that is to flip the bottom one over, the one you're divided by, and change it to multiplication. Okay? So 332 over 570 divided by 508 divided by 570 is the same as 332 over 570 times 570 over 28. Notice the bottom one is flipped over. So flip the bottom one over, change it to multiplication, right? And now you notice, hey, I have a common factor between the top and the bottom, right, of 570. So you would think you can cancel common factors between the numerator and denominator. So 570 goes into 570 one time, right? And 570 goes into 570 one time, right? So I can cancel those out. And now to multiply two fractions, right, you just multiply across the tops. 332 times 1 is 332. And 1 times 508 is 508. And so you can see we get exactly the same answer that we got from before as a fraction. Okay. And so you may have a preference of one of these over the other, right? And you know, on the test or quiz or whatever, I'm not going to tell you what method to use. So if you have a frequency distribution like this, you know, and you find this method easier, right, by crossing out rows, which you got to admit is pretty straightforward, then go ahead and by all means use that. Okay. The thing is, though, is there are going to be some problems where you will have to use this conditional probability formula. So you can't completely get away from learning it. You have to do that. And we'll take a look at one of those examples later. All right, so that's it for this one.